All right, welcome back, Chem Team. This is the first video notes coming at you about atomic structure. And in this video, we're going to explore atomic number and mass number and learn to start using the periodic table a little bit. So in class, we've been discussing exactly what it means to be an atom and how we've gotten there through our atomic theories. And we know that an atom is the smallest possible piece of an element you can get to and still maintain its properties. So if you keep on breaking an element down and still want to have that element, the smallest piece you can get to is an atom. And we get that word atom from the Greeks, and with the Greek word, it means indivisible or uncut, meaning you can't break it down or get any smaller. And so we've gotten to a bunch of different theories and models, and here's one of them that we've started to look at. And this is probably one of the most common ones you see in public, where if you think of Jimmy Neutron, Big Bang Theory, and things like that, typically they're going to show you a model that looks like this. Now, this is probably not the most accurate for what an atom actually looks like, but when it comes to actually figuring out where things are in the atom, we have to come up with simpler ways to draw it out, because an atom is actually very complex. So we usually draw them out a little more simpler than what they actually look like. So if we were actually looking at this atom and wanted to identify its pieces, we see that we have this big glob of things in the center, and then we have things which appear to be moving around the outside. And so we have this piece in the center, which is called our nucleus, and there are two different types of particles in it. And then we have these particles on the outside moving around the nucleus. Okay, so we're going to use a simulation to help us make some sense out of what this is. All right, so we know from some of our previous science classes and what we've already learned so far that we have protons, neutrons, and electrons inside of an atom. So even though we can break an element down to its simplest form and be an atom, we can actually break an atom down even further, and it has these three basic parts. And inside the center of our atom, in the nucleus, you're going to find protons and neutrons. And as I threw those in there, you can see as soon as I put in that hydrogen, or that first proton, it identified itself as hydrogen. If I add another one of these protons, it changes the identity again. So we have our periodic table up here on the right. And as we're adding more and more protons, it actually is changing the element. If I add neutrons, it doesn't change the element, but they're going into the nucleus. And what the neutrons are actually doing are affecting my mass number. So if I add more neutrons, my mass is going to increase. Now the electrons, and this is a 2D model, end up on the outside of my nucleus in what we're going to call orbits for right now. Now this gets a lot more complicated. We'll be talking about this later on when we get in more detail about atomic structure. And what these electrons do is they actually tell us our charge. And you see I got positives are red, negatives are blue. So my protons give me positive charge, my electrons give me negative charge. So right now I have a net charge of 0 because I have 2 protons and 2 electrons, so they are canceling each other out. Okay, so let's actually fill in our table based on what we've looked at so far. Okay, so putting that atom together really quickly, we know that a proton is going to be found in the nucleus. And we also know that in the nucleus we have the neutron. So both the proton and the neutron are both found in the nucleus. And for now, we are going to say that the electron is found outside the nucleus. This will get more complicated, but for today, outside the nucleus. Mass gets a little bit trickier. When we start talking about mass, remember we're dealing with particles that are extremely small that we can't even see with a microscope. So if we look at their actual mass, this is in kilograms, 1.7 times 10 to the negative 27th for a proton. So if you think about how small that is, that's a decimal point with 26 zeros after it, and then a 1/7. And if you look at an electron is even smaller. It's over 1,000 times smaller than our proton and our neutron. But our proton and our neutron both have the same, or very close to, the same mass. Now, in chemistry and in science, these actual masses are not really something we want to work with on an everyday basis. So for our introductory to chem things that we're working on now, we're going to use what's called an atomic mass unit, and it's abbreviated as AMU. An atomic mass unit is 1/12 the mass of carbon-12 nucleus. So basically, a carbon-12 nucleus has 12 things inside of it. 6 protons and 6 neutrons. And if you take 1/12 of that, you get 1. So this gives us an atomic mass unit that's very easy to deal with. So a proton has an atomic mass unit of 1. And just like you see here with protons and neutrons having the same, very close to the same actual mass, they both have an atomic mass unit of 1. Now an electron, since it is so much smaller than a proton and a neutron, we don't worry about it actually having a mass for our introductory chem things that we're working on right now. So when we say it's atomic mass units, it really doesn't have a mass that's going to affect what we're doing in chemistry class right now. Charge. So charge is what they actually get, positive or negative, and how they affect the overall charge of the atom itself. So protons are positive, electrons are negative, and neutrons are neutral, just like the name implies. So neutrons do not have a positive or negative charge. And we see these symbols. For a proton, it's going to be a lowercase p with a superscript plus. An electron is a lowercase e, superscript minus. And then a neutron is just a lowercase n, and then sometimes you'll see a superscript 0 up to the right. Alright, so from here on out, you're going to need to have your periodic table in front of you. So please get that out and have it ready to go. We're going to be looking and referring to this to complete the next few parts of our set of notes. Alright, so in your packet you have there, in your notes, you have atomic number. An atomic number is what we refer to as the number of protons in a nucleus, and it's how we identify elements. So every element has a unique atomic number. And so the number of protons inside the nucleus tells us exactly which element it is. Okay, so we actually use the periodic table to help us out with this. So we have some examples down here. So we have, for number 1, we have an element that has 11 protons, our P+, 12 neutrons, and 10 electrons. So if we wanted to identify it or figure out its atomic number, we would only look at the protons. So once we know we're looking for 11 protons, go back to your periodic table, and your periodic table is set up so that it actually goes in order from left to right, just like if you're reading a book. Now there's some gaps in there, but if you just keep following the rows, you'll eventually get there. And we are looking inside each box for the element. The atomic number is going to be in the lower left on your periodic table. So we're looking for, what is number 11? So we look for number 11, and that's right there, and our symbol is Na. So we identified this first one as Na, which is sodium. Alright, let's try the next one. The next one here, number 2, has 16 protons, 16 neutrons, and 18 electrons. Again, if we want to identify the element, we only need to worry about just the protons. So we're going to go look again right back at the table, and we're going to go look for number 16. So if we follow it along, 12, 13, 14, 15, 16 is right here. So we are looking for this element if we had to identify it. And so that element is sulfur. And now I want you to actually see if you can identify number 3, the element that has 25 protons, 30 neutrons, and 23 electrons. And go ahead and write that into your notes. All right, the next piece we're going to look at for tonight is mass number. And if you think back to the simulation we were looking at right at the start, the particles that affected the mass as we added them were the protons and the neutrons. So mass number, which is only deals with one atom, is the amount of protons and neutrons in the nucleus. Okay, and there are numbers on the periodic table that are going to be close to this, but not exact. So you can't just round. You actually have to look at what is in that atom's particular nucleus. So for example, if we want to determine the mass number for the following atoms, so for number 1, if we have something that has 11 protons, 12 neutrons, and 10 electrons, we know that the mass number is only going to be equal to the protons and neutrons added together. So our electrons are not going to affect our mass number. So in this case, our mass number is going to be equal to 11 protons plus 12 neutrons. So our mass number is 23 atomic mass units. And let's go back and look at that element on the periodic table. It's number 11, it's sodium again. And you see how it came up to 23. And if you look at this number here, which is called the atomic mass, it's very close to that, but it's not exactly a whole number like atomic mass units. And this atomic mass we'll talk about later is actually an average of the isotopes of sodium. So that's going to be close to one of your values, to your mass number, but it's not always going to be exact. Alright, so for number 2, again, if we want to find the mass number, we know we're only going to deal with protons and neutrons when we worry about mass. So our mass number for number 2 is going to be 16 plus 16. And for this sulfur atom, its mass number is 32 atomic mass units. All right, find the mass number for number 3, write that in your notes, and we will pick up with this tomorrow.